right, well, we have a special episode today, and we're going to walk through how to interpret a CPC, Climate Prediction Center map, because we show these all the time, and we kind of have this, um, this expectation that everybody is familiar with them, but really there's a lot going on in them. And to be honest, a lot of the people that work here at the National Weather Service probably don't have an understanding themselves about what is going on in these maps. So let's go ahead and talk about them. All right, so here's a sample map. This is kind of what we show all the time, right? Of in this case, it's an 8 to 14 day, or what we call a week 2 outlook. And it's got these 3 categories on it. In this case, this is a temperature map that has below normal, near normal, and above normal. We might think, oh, here we think we're calling for it to be cool here and warm here. But really, that's not what this map is showing. It's showing a lot more kind of granularity in there. So let's go ahead and talk about it. First thing we need to talk about is this concept of a tercile. Okay, so what is a tercile? Well, terciles are thirds of a distribution. There's a lower third, middle third, and an upper third, and we use these in terms of our 1991 to 2020 climate normal period. That's the current climate normal period and will be for the next 5 years. For temperatures, we use average daily temperature, not high temperature, not low temperature, average daily. Because over a week-long period, month-long period, season period, doesn't matter highs and lows. It all gets thrown in the same bin, and we turn the crank, and it's average normal temperature. Okay, and crucially, these are categorical probability temperatures. We make no statement about, 10 degrees above normal, or 5 degrees below normal, or twice as much precip as normal, or no precip. None of that is in there. Some of it's kind of implied, and that's okay, but that's not actually part of the official forecast. All right, so let's talk terciles. And using that map we showed a minute ago, here are some terciles for the Anchorage International Airport for the April 26th to May 2nd period. Right, so we look at all 30 years from 1991 to 2020. We compute the average for this 7-day period, and then we order it from lowest to highest. And so we get this distribution right here, and we just break it into thirds. We have the lowest third, which is everything 41.9 degrees or lower. We have the upper third, which is everything 44.6 degrees and warmer, and the middle third, which is in between. Okay, so thirds of the distribution. We are not splitting this in half. We're not saying warmest half, coolest half. Thirds. It's very important. Thirds. And we do the same for precipitation. We take all 30 years with the April 26th to May 2nd period. We sum up the precipitation at all locations. Again, this is the Anchorage example. And we cut it into thirds. And in this case, this is a dry time of the year. The lowest third is 1/100th of an inch or less. The wettest third is 8/100ths of an inch or more. But for precipitation, it's really tricky because precipitation is not normally distributed. It is highly skewed, especially during the dry time of the year. In fact, the average precipitation for that period, if you add up all 30 and divide by 30, is actually in this upper tercile. Okay, but we are not talking about averages. We are talking about thirds. Okay, so in the thirds, we got 0.02 to 0.07 precipitation. We would call that our middle third of our distribution. Okay, so we're going back to this map here. Now we can describe a little more coherently that we're talking thirds of the distribution. So up here on the north slope in this example, this is the 40 to 50% chance of being in that coldest or lowest precipitation. But it also includes a chance of being in that middle third of the distribution. It also includes a probability of being in that warmest third of the distribution. And then the opposite down here on the southern mainland, 40 to 50% chance of being above normal or in the upper distribution, a 33% chance of being in that lowest distribution. In this case, a 17 to 27% chance of being in the lowest third of the distribution. So really there's three things going on here. You could make this into three different maps. If we add these little pie charts to it, I think it helps to make it a little bit clearer. Here at Upyogvik, it's showing that there is a 46% chance of being in that lower third, a 33% chance of being in that middle third, and a 21% chance of being in that upper third. So again, this is not a 46% chance of it being colder than normal. It is a 46% chance of being in that lower tercile. Conversely, here in the southern part of the state, we'll use Anchorage as the example. Anchorage has a 39% chance of being in that upper tercile, a 33% chance of being in that middle tercile, and a 28% chance of being in that lower tercile. Okay, so there is still a chance it could be below normal, but the favored category is what we map. The favored tercile is what we map. In this case, in the southern mainland, the favored tercile is being in that upper category. In the North Slope, the favored tercile is that lowest third, that lowest tercile. Okay? If we think of it in terms of a table, of course, all those numbers have to add up to 100%. We are 100% certain it'll be in that lower tercile or lower, the middle tercile, or the upper tercile. And again, those are unbounded, right? If we go back to this, lower tercile could be way over here too, right? So we're just saying lower tercile is less than or equal to, in this case for Anchorage, 41.9. Upper tercile is greater than or equal to 44.6. But it could be much greater, or in this case, much lower. Okay, so again, back to our table form, we say it's 100%. 100% chance will be lowest or lower, middle, or highest or upper or beyond. Okay, so this is what it looks like just in the colors. And we generally reserve 33% for this middle category, and we always reserve at least 3% for the non-favored category. So we would never say there is a 0% chance of some outcome. There's always at least a 3% chance when we think about this in probabilistic space. Okay, if we actually try to throw some numbers at this for that same period, April 26th to May 2nd, remember our map here, our three favored categories. Up here in the North Slope, that was the 40 to 50% probability. And so we are saying there's a 40 to 50% chance that we will be at or below this lower tercile breakpoint. So that's one side of the equation. But we're also saying that there's a 17 to 27% chance that we are above that upper tercile break. Okay, so above, in this case, 25 to 30 degrees, there's a 17 to 27% chance. But we're also saying there's a 40 to 50% chance that we'll be below 15 degrees. So that may sound like there's not a lot of confidence. And again, for a week 2 period, there's lower confidence than there is for tomorrow. But that's the way we think about it. Again, all possibilities are on the table, but one is a favored possibility. And the same here for the southern mainland. We would say there's a 40 to 50% chance of being in that upper tercile, so at least this temperature, but that there's still a 17 to 27% chance we will be lower than this lower tercile temperature. Okay. Now, for monthly and seasonal outlooks, we don't use the near normal very much. Sometimes we do, but usually you'll see this term equal chances. Equal chances does not mean a forecast to be near normal. It's very, very important. It does not mean that. It means there's an equal chance that will be in either of those three categories. Equal chance that will be in the upper tercile, the middle tercile, or the lower tercile. We do reserve a case for a specific forecast that we're going to be in that near normal. if you see that gray color on this map, which you don't in this example, that would be indicative of that. But normally we say equal chances, okay? So again, it's not a near normal forecast, it's equal chances. Now we do have a website here at the CPC, just Google CPC, National Weather Service, and there's a link to an interactive guide. And so if you click on the Alaska one, you can click anywhere on the map, and it'll give you these little pie charts. It'll give you, here's the chance of being in that upper tercile, middle tercile, lower tercile for both temperature and precipitation. You can get really granular data. Now, they're not, eyeballing every little spot saying, oh, what do we think it's going to be? We draw these lines and then we interpolate between the lines. But again, these are probabilities. These are not temperatures. These are not, we're not saying it's going to be X degrees or, X amount of precipitation. We're saying this is the probability of being above or below normal. And going back to this, above or below normal. What is normal? It varies widely across locations, but even two locations that are very near each other that might have vastly different normal temperatures, say because of elevation, it's exceedingly likely that, if Anchorage is above normal, that Chickaloon's also going to be above normal. Or if Nome is going to be below normal, that White Mountain will also be below normal. So even if their normals are different, we think of these in anomaly space, they would probably be in the same category. All right, so that is our in-depth talk about our Climate Prediction Center maps and how to interpret them. If you have any additional questions or if something was confusing, drop a comment in below and we'll get back to you as soon as we can. So thanks everyone, and until next time, we'll see you later.